Happy Friday! Here we go. It's day 2 of section 8.4. Yesterday we learned about infinite sums, or sums of infinite sequences and series. Now, I will tell you this. If you were not in class on Thursday, you should stop this video right now, watch Thursday's video, learn that material, then come back and watch this video once you've learned that, and so on and so forth. Okay? So you've got that option today because it's a Chromebook and earbuds day. Okay? So if you weren't here yesterday, you should be watching yesterday's video right now. Okay? For those of you that are still here on the video now, what I would like you to do is, these are warm-up problems number 1 and 2. They are also on your note sheet / homework sheet. So what I would like you to do is I would like you to think about what we learned yesterday and do these 2 problems right now. I'm going to let the video play while you're doing them. Might even play a little music. I'm still here, just playing some music. So you should be almost done by now. So I am going to start these now. If you're not done, pause the video here and finish with these problems, then restart the video. Okay? So the first thing that we need is we need to look at our R value. If our R value is greater than 1, then no sum exists. Okay? And so this R value here would be negative 10 over 9, and that is bigger than 1. It's actually approximately negative 1.11111. Okay? So that means that no sum exists because our R value is not between negative 1 and positive 1. So no sum exists. Again, we look over here, we look at our R value. Our R value here is 1/5. That falls within our range between negative 1 and positive 1. So that means then that we need to find the first term. If I find the first term, I'm going to take my starting value, I'm going to put it into my function. So that's going to be negative 5 times 1/5 to the first power. Negative 5 times 1/5 to the first power is negative 5 over 5, which is just negative 1. since our sum exists, then now we can say, and we've got our first term, so the sum here of an infinite series is going to be our first term divided by 1 minus r. Well, our first term is -1. We're going to divide that by 1 minus our r value is 1/5. Okay? Well, doing some fractions, 1 minus 1/5 is 4/5. Dividing by a fraction is the same as multiplying by its reciprocal. So we got that. So the sum here of all of these terms in this sequence is -5/4. Okay. Now, what we are going to be doing today is we are going to be converting repeating decimals into fractions using infinite geometric series. Okay? Why do we want to do this? Well, everybody loves fractions, so we want to get it into a fraction part. So, the first thing that you are going to want to do is you are going to want to look for the repeating part. Okay. In this particular case, it's the 5 that is repeating. So I could write this decimal as 0.5 plus 0.05 plus 0.005 plus 0.0005, and so on and so forth. Okay? Now what I have is I have an infinite geometric series. And so what we can do with that is we can say, well, the very first term in our infinite geometric series is 0.5. Then we can find our r value. Our r value is found, like we've been doing this for a week, take any term and divide it by the term right before it. Okay? Well, if I were to do that, I would get 0.1 if I used a calculator, or if I did some fancy math stuff, and I move this decimal point over 2, then I'm going to have to move this decimal point over 2, and I get 5/50, which reduces down to be 1/10. Both can be divided by 5. So my r value here is 1/10. And hey, look at that. R is in the range of -1 to +1. We know the first term, we know our r value. So the sum of the infinite geometric series that includes these numbers then would be my first term, which is 0.5, 1/2, if you will, because we want to go into fraction form. Let's get it in fraction form. Okay? Divided by 1 minus my r value, which was 1/10. Okay? Well, 1/2 is 1/2. 1 minus 1/10 is 9/10. So if I wanted to divide by fractions, I'm going to multiply by reciprocals. So then that becomes 1/2 times 10/9. 2 goes into 10 5 times. So the sum of this infinite geometric series is 5/9, so that means then that 0.5 repeating is equal to, in fraction form, 5/9. So we first look for what's repeating, then we set up an infinite geometric series to go on with that, and then we find the sum of that infinite geometric series. That gets us our fraction form. Okay? Now, again, we look for what's repeating. Okay? Just remember that you can pause this video at any point in time to catch up. Okay? I'm trying to keep the video under 15 to 20 minutes. So right now we're at 11 minutes, so we're good. All right? So what's repeating? Well, the 146 is what's repeating. Okay? So I can write this as 5 plus 0.146 plus 0. Now I've got to fill in 3 spots because I used 1, 4, and 6. And so then it's that. And then I've got to fill in 1, 2, 3, 1, 2, 3, 1, 4, 6, and so on and so forth. Okay? So if I would combine all those together, I get that number that's up there in between convert and 2. So this 5 out here, I'm going to save for later. So I'm really just going to look at the part that is repeating. Okay? Well, if I look at the part that's repeating, my first term is equal to 0.146. This right here now becomes my first term. My R value is going to be 0.000146 all over 0.146. And again, if I think back to my math, I got to move decimal places. So I'm going to move this decimal place 1, 2, 3, 4, 5, 6. So that gets me to 4 zeros in front and then 146, which we'll just write as 146. Then I got to move this decimal place 1, 2, 3, 4, 5, 6, and I fill in with those zeros. So that gets me as 146,000. Now, if I reduce that, I can reduce this by 146 goes into 146 one time each. So that leaves me with an R value here of 1 over 1,000. Okay? So now I can find the sum of that, of just the repeating part. Oops, let me pull this back up so that it's still on there. So the sum of just the repeating part is going to be start over again. 0.146 divided by 1 minus 1,000th. Now, 1.146 in fraction form would be 146 over 1,000. 1 minus 1,000th would be 999 over 1,000. So I would take the top fraction, leave it as is, reciprocate the bottom fraction, multiply, my 1,000s cancel each other out, and that leaves me with 146 over 999. But I've got this 5 still sitting out there. So now what I'm going to do is now I am going to bring that back into play. And so my final answer is going to be 5 plus that fraction. Okay. So that would then be, now I got to get common denominators. So 999 times 5 is going to be 5, carry the 4, 9, carry the 4, 4,995. So this is 4,995 all over 999. Do the math. 4,995 divided by 999 gets me 5. Plus 146 over 999 gives me my final answer of 5.14616. Repeating is equal to 5,141, adding the two tops, all over 999. Okay. What I'd like you to do right now is I'm going to play some music again. I'm going to give you about 3 minutes. That puts me at the 20-minute mark. And then I'm going to let you do this problem by yourself. Then I will go through it. You may begin. Gotta find some music.
Sideways. We back in the speakers, back in black, getting blasted in the bleachers. It's probably true what my mama said. I do it just like my daddy did. We back in the saddle, back on stage, making the whole place rattle. Back with the hits and the train on the track. Thought we were gone, but you know that was all we had. Where's the chick wearing blue jeans, a little too tight? Got a grip on coos if it's what she likes. Getting picked up in a pickup and kicking every guy's like us. We back in the speakers, back in black, getting blasted in the bleachers. It's probably true what my mama said. I do it just like my daddy did. We back in the saddle, back on stage, making the whole place rattle. Back with the 18 train on the track. Thought we were gone, but you're wrong. Now it's so we back. Sun comes up and sun goes down. Yeah. Everything good comes back around. We back in the speakers, back in black, getting blasted in the bleachers. It's probably true what my mama said. I do it just like my daddy did. We back in the saddle, back on stage, making the whole place rattle. Back with the 18 train on the track. Thought we were gone, but you're wrong. Now it's on we back.
All right, I'm back. So this would be 10 plus 0.36 plus 0.0036 plus 0.000036, and so on and so forth. So again, we're going to take this 10 and we're going to save it for later. Okay, so that gives me a first term in my sequence of 0.36. That gives me an R value in my sequence of 0.0036 over 0.36. Move at the top one 4, 1, 2, 3, 4. Bottom one 1, 2, 3, 4. Fill in with 2 zeros. That's going to be 36 over 3600, which reduces down to this one. R is 1 over 100. So the sum is going to be 0.36 over 1 minus 100. 0.36, that is, oops, this should have been in purple. My bad. My B. 0.36, that's 36 over 100. I don't know why I keep putting that equal sign way up there. I should know it's going to be down here. And then 1 minus 100th is 99 100ths. So that's going to be 36 over 100 times 100 over 99, which is going to be 36 over 99. Now, 36 can be divided by 9. 99 can be divided by 9. So if 9 goes into 36 4 times, 9 goes into 99 11 times. So my sum here is going to be 4 11ths. Always reduce whenever possible. Okay? So I should put that actually over here as 4 11ths. Then, now I can bring the 10 back into play from way back up here. Oops, whoa, that went all the way. We don't want that. We want just that. There we go. So this is 10 plus 4 11ths. Well, 10 is 110 11ths plus 4 11ths gets me is equal to 115 equal to 114 over 11. Now, the note sheet that you've been using is a dual purpose sheet. That dual purpose sheet is now there are 3 homework problems on the back side that you can do for the rest of class. You could get it done and then have no homework for the weekend, Yahoo for school, or you could wait until Sunday night or Monday morning to do it. But that sheet, one side is going to be your notes. I'm going to grade your notes. The other side is going to be your homework, and I'm going to grade your homework. So this sheet is worth 6 points and is due on Monday. Thanks for playing along. Have yourselves a great weekend, and we'll see you on Monday.